I'd like to thank the organizers of the Tech Topology Conference for having me once again, and you for your time if you're viewing this. I'd like to speak about the thin knots and cabling conjecture. This is an open problem regarding Dehn surgery, a construction where you excise at the neighborhood of a knot from the 3-sphere and fill it back in with a solid torus determined by where the null homologous curve gets mapped. In the case that our surgery along K is reducible, then such a slope is called a reducing slope. And the principal example to have in mind is if K is the PQ cable of some other knot. In this case, you have that the reducing slope is integral and you admit a lens space summand. The cabling conjecture of Gonzalez-Acuna, in short, asserts that this is the only example that can occur. And it's been verified for torus knots, satellite knots, and alternating knots. So it suffices to look at hyperbolic knots. So recall that a knot is Floer homologically thin if every generator of knot Floer homology is the same delta grading, and a knot is an L-space knot in the 3-sphere if it admits a surgery to a manifold with the simplest possible Hegardt-Floer homology. The result I'd like to speak about is that if a thin hyperbolic knot admits a reducible surgery, then the knot must be an L-space knot and the reducing slope must be maximal. It's 2g minus 1 after mirroring the knot to make it positive if necessary. It's worth pointing out that it's conjectured that there are no thin hyperbolic L-space knots. This would be the case if knot Floer homology does detect the 2n torus knots. However, the only alternating L-space knots are the 2n torus knots, so this does at least serve as a reproof of the verification for alternating knots. And it's not too difficult to see that thin slice knots satisfy the conjecture as well. So to establish this, we involve Hegardt-Floer homology using immersed curve invariants. For a manifold to torus boundary, Hanselmann, Rasmussen, and Watson associate this curve invariant in the punctured torus. Below is an example for the figure 8 knot complement seen on the left and the middle in the punctured torus. And on the right, this curve invariant is lifted to the infinite cylindrical cover. You note that this lift of the invariant encodes properties of the knot. For example, the genus is the height that the highest component crosses over. And gamma, the essential component, encodes concordance invariants of the knot. Oshvat and Savo's tau invariant and Hom's epsilon invariant are recorded by this component. Okay, so we introduce these curve invariants because the Floer homology of gluing can be recovered by taking the intersection Floer homology of the pairing of the respective curve invariants. And this pairing respects the relative Maslov grading and spin CD composition. In the computations for thin knot complements, the Maslov grading differences can be expressed geometrically and have a fairly simple form, being determined by the number of enclosed base points and then tau of the knot and the height the intersections appear at. Okay, so subjecting surgery to this construction, we have that the Floer homology of a reducible surgery is the intersection Floer homology between the curve invariant for the knot complement. Here on the left, it's been lifted to the tiled plane cover. And the curve invariant for the filling solid torus is a line of slope r. And to recover the S spin C summand, this line crosses at height S. We'd like to collect relative grading differences between some chosen intersection, and then inspired by Hanselmann's approach to the cosmetic surgery conjecture, we collect all of these into a multiset where repetitions are allowed and try to use this as an obstruction for different spin C structures to support relatively graded isomorphic Floer homology. This provides an example here with a genus is 6 and tau is 0. We see that the component that crosses the figure 8 at height g minus 1, that S prime spin C structure has the widest width of grading differences, and so it can't be relatively graded isomorphic to anything else. But for reducible surgery, there is a periodicity experienced by the spin C summands. And altogether, this would imply that one of the connected summands of surgery should be an RP3 component, but then the other one would need to have even H lower 1, which can't happen if since the Floer homology or the H lower 1 of surgery is cyclic. There are other cases to consider. In the future, I'd like to involve the mapping cone formula information with the immersed curve information more directly. Involve HF plus and the D invariant some more, And I think this in total can be used to great effect to bound the surgery slope in terms of the genus, tau, and the thickness. Thank you for your time.